Okay, today's topic is about problems with multiple contact surfaces. For both of the problems down below, we have multiple contact surfaces. And if you remember in section 9.1, we talked about wedges, and wedges have multiple contact surfaces. The kinematics for the problem on the left, though, is straightforward. If slip occurs or is impending on one contact surface, then slip will occur or be impending on both of those contact surfaces. So let's kind of zoom in here a little bit and take a look. So if we see, as this rope is pulled, that we see it has to slide on both B and C, right? So even though they have different coefficients of friction, the only way for this cable to actually move or have impending motion is if it slips on both of those contact surfaces. However, if we look at the second example, we see the kinematics for this problem on the right is a little bit more complex, and we can say that it's really not likely that both of these will slip simultaneously. So if we look at this, it's very unlikely that we would see both of these slide, right? It's very unlikely that that would happen. More likely what would happen is one of these would slide, right? Either B or C would slide, depending on their coefficients of friction and all of that. It would be dependent on either of those, right, and the weight of them. So the question is, how do we solve problems like this with these multiple contact surfaces that we aren't sure which one is going to slide? So the methodology of solving these types of problems is really to look at each of those surfaces independently. A common error typically is that people tend to assume that right from the beginning that force, that frictional force, has to equal mu n without looking at all of the surfaces and which one will slide. That is a big mistake that everyone tends to use. Of course, that is the case in this one on the right. They both have to slide, right? Both at B and at C has to slide simultaneously, but that is not the case with this one on the right. So most of the time with cases of multiple contact surfaces, like the example on the right, we don't know which surface will slide and which one won't. So how do we deal with that? We remember that this is equal to, force is equal to mu n only for impending slip. And then we use the static coefficient of friction. If it's moving, then we use the kinetic one. I will tell you right now, none of the problems we deal with will use this kinetic coefficient of friction. It's always the static one that we'll be looking at. Otherwise, for other surfaces, we know that it has to be less than that. So it can be some value less than that when we look at it. And these expressions assume that this frictional force F is, of course, in the right direction, that we know the right direction on where the slip is going to occur. So how do we solve problems like this? We're going to take a look at that in an example down below.